Okay, the complex number system is an extended number system that includes the real number system as a subset. For this number system, we define I as the square root of -1, or I squared equals -1. Numbers of the form a plus bi, where a and b are real numbers, are called complex numbers in standard form. A is called the real part, and b is called the imaginary part. And here are some examples. Now, this is a review. We have done this both in Algebra 2 and Algebra 3, so most of this should sound very familiar. The number -8 is a real number, and it can be written as a complex number in the form -8 plus 0i. The number 0, also real. It can be written as a complex number as 0 plus 0i. 3i is an imaginary number, but it can be written as a complex number as 0 plus 3i. -i plus 2 is automatically complex, it's imaginary. And in standard form, it's 2 minus I because the real part always comes first. And then 8 plus I squared of 3, again imaginary, it's already in standard form. This is how the number system all fits together. And again, this should be a review. At the far right, we have integers. By the way, whole numbers and natural numbers go into making the integers. The integers are your positives and negatives, but no decimals or fractions. Then the non-integers would encompass your decimals and fractions. And when you put those together, we have the rational number system. The rational number system encompasses all numbers that can be written as a fraction. The irrational numbers are those numbers that cannot be written as a terminating or repeating decimal or as a fraction. For example, pi is irrational, e is irrational, the square root of 2 is irrational, the square root of 3 is irrational. When we combine the irrational numbers with the rational numbers, we have the real numbers, and they can be written as a plus bi, and b would be 0. The non-real complex numbers are the ones that are in the form a plus bi, where b is not equal to 0, and the real numbers and the non-real complex together form the complex numbers, a plus bi. Again, real numbers can be written as complex. The b is just 0. Okay, some examples. First of all, notice that we're going to write the square root of a negative number as I times the square root of the positive of that number. So what we're going to do here is we're going to do a little simplifying. For a, we have the square root of -16, and for b, we have the square root of -75. Pause this recording, give the problems a try, and resume the recording to check your answer. Okay, the square root of -16 is the square root of -1 times 16. Square root of -1 is I, so that comes out in front. And the square root of 16 is 4, so the answer is 4i. For the square root of -75, we have I times the square root of 75. 75 is 25 times 3, and 25 is a perfect square. So we have 5i square root of 3. Okay, products and quotients involving negative radicands. By the way, the radicand is the number that is under the root symbol. Before using rules for operations with radicals, you must rewrite any square root of a negative number as I times the square root of that number. That is very important. Don't forget, you must do that first. If you do not, you will very likely get a wrong answer. Okay, let's try a couple of examples. We're going to solve the square root of -6 times the square root of -10. Pause the recording, give it a try, and resume the recording to check your answer. Okay, we pull out the I first, so we have I square root of 6 times I square root of 10. I times I is I squared times the square root of 60. When we split 60 up, we find that it's 2 square root of 15. And I squared is -1, so we have -1 times 2 times the square root of 15. And that is -2 square root of 15. Now try this problem. Again, pause the recording, give it a try, and resume the recording to check your answer. Okay, again, we pull out the I, and we have I square root of 48 over the square root of 24. When you have a square root on top of a square root like this, you can go ahead and divide them. 48 divided by 24 is 2, so we have I times the square root of 2. Okay, a little bit about technology. We have graphing calculators that are capable of complex number operations. And it even has a mode for that. So you can go press the mode button and go down. You'll see where it has the option to set it to A plus BI. So looking at our last problem, we put in the square root of negative 6 times the square root of negative 10, and we have negative 7.745, etc. Now, that doesn't help us a whole lot, so we're actually going to put our answer in also, which was negative 2 square root of 15. And we see that that gives us the exact same answer. So you could see that this actually does work. If it's not in A plus BI mode, very likely will give you an error. One more really important thing. When you put complex numbers in your calculator, you must use the key that is designated for I, for this particular value of I. And that key is the second, then the decimal. And you'll see it there in the second color. Any other key will result in a wrong answer or an error. So do not use the alphabet I. Use the I that is specifically set apart to equal the square root of negative 1 on your calculator. And again, that is the second button and then the decimal. Now, all the properties we've learned for real numbers are also extended to complex numbers. For example, adding and subtracting complex numbers. We've done this before. See if you can remember. Pause the recording, give it a try, and resume the recording to check your answer. And here we have them. For A, we have 3 minus 4i plus negative 2 plus 6i. We just add the real parts, so 3 plus negative 2 gives us 1. And we add the imaginary parts. Negative 4i plus 6 is 2i. For part B, same idea, but we need to be careful because of that minus. So we have negative 4 minus 6, which is negative 10, and then we have 3i minus negative 7i, which is going to give us 10i. Multiplying is going to work very much like binomial multiplication works. We're going to use FOIL on this. And the other thing you need to remember is that when you multiply I times I, you get I squared, and I squared equals negative 1. Pause the recording, try this problem, and resume the recording to check your answer. Okay, here you see we have used FOIL. 5 times 7, 5 times negative 2i, negative 4i times 7, and negative 4i times negative 2i. That gives us 35 minus 10i minus 28i plus 8i squared, which is 35 minus 38i plus 8 times negative 1, which gives us 27 minus 38i. And here it's done on the calculator, and you can see the same result. We're going to look at what happens when you raise I to different powers. I to the first equals I. Anything to the first equals itself. We already said that I squared is negative 1. I to the third is I squared times I, which is negative 1 times I, which is negative I. And then I to the fourth is I to the third times I. We just said I to the third is negative I. So it's negative I times I, or negative I squared, which is negative negative 1, which is 1. And then when you go to I to the fifth, it starts all over again. I to the fifth will be I to the sixth will be negative 1. I to the seventh will be negative I to the eighth will be positive 1. And you're going to see this repeat every 4 numbers. Any large power of I can be found quickly by writing the power as a product of 2 powers of I. one exponent would be a multiple of 4. So you're going to split the exponent up into two parts, and one of them is going to be a multiple of 4. Okay, we're going to try to simplify I to the 13th power. Pause the recording, give it a try, and resume the recording to check your answer. Notice what we've done here. We've split I to the 13th up into I to the 12th times I to the 1st, because remember, when you multiply numbers, you add their powers. So I to the 12th times I to the 1st will be I to the 13th. Now, why do we pick 12 and 1? We want one of those two numbers to be a multiple of 4. Well, 12 is a multiple of 4. In fact, as you can see here, it's 4 times 3. So we have I to the 4th raised to the 3rd times I to the 1st. The I to the 4th is 1. So we have 1 to the 3rd, and then I to the 1st is just I. So 1 times I is I. Now let's try this with a negative. Think about what we just did. Give this a try and resume the recording to check your answer. Really, we just did the same thing. We split -3 up into -4 plus +1. So we have I to the -4 times I. I to the 4th power is just 1, and 1 to the -1 is 1. So we end up with, again, just I. Now we've talked about conjugates before. We did this in Algebra 2 and Algebra 3. The conjugate of the complex number a plus bi is a minus bi. Notice that the numbers are the same. The signs in between are what is changed. When you multiply these two together, you get a squared plus b squared. Notice that the I has gone away, and that's one advantage to knowing the conjugate of the complex number. Okay, we have a table that's going to show some pairs of conjugates and their products. So if we have 3 minus I, the conjugate is 3 plus I. You can see there how we multiplied them together and gotten 10. 2 plus 7i, the conjugate is 2 minus 7i, and we get 53. And then -6i and 6i, and we get 36. Notice that the products of a complex number and its conjugate, the product is always going to be a real number. When we divide complex numbers, we're going to multiply the numerator and the denominator by the complex conjugate of the denominator. Remember, I is the square root of -1, and as we've said in previous years, you really are not supposed to leave a square root down in the denominator of a fraction. So we need to remove the I just like we would need to remove a square root. And in order to do that, we're going to multiply by the conjugate. We're going to multiply both the denominator and the numerator, because anything we do to the denominator, we're going to have to do to the numerator. So here's an example. We're going to find the quotient of 3 plus 2i over 5 minus I and write it in standard form. Pause the recording, give this a try, and resume the recording to check your answer. And here's our solution. We multiply the top and bottom by 5 plus I. Notice on the top we need to FOIL this out. Don't forget that I times I is I squared. And the denominator, we also FOIL that out. It gives us 25 minus I squared, which again, I squared is -1, so we have 25 minus -1, which is 26. We've combined our like terms on the numerator also, and we have 13 plus 13i. And then we split it up, because remember, standard form is a plus bi, two separate numbers. So how you split it up is you just give each part of the numerator the denominator. 13 over 26 plus 13i over 26, and 13 over 26 reduces to 1/2. So we have 1/2 plus 1/2 I. For the rest of this recording, we have some problems for you to try. I would pause the recording, give them a try, and then resume the recording to check your answers, and proceed like this for the rest of the recording.